In this lesson, I will teach you how to write variables, what they're used for, how to name them, and how to store data in them. First off, we have different data types. When you write a data type such as int, it will turn blue. This is a reserved word. Int stands for an integer. When you create an integer, you must name the storage. So int is the data type. The name of the storage I will call num, and it ends with a semicolon. So in this case, our variable num stores an integer. An integer is a number which is not decimal. It's a whole number. It can be positive, negative, or 0. So to add contents to num, here we simply place the number 7 inside of num. From now on, num will hold the number 7 unless num is replaced by a different number, such as, in this case, I will go ahead and display onto the screen. The cout stands for computer out, and it's going to output num, and then it's going to end the line. This is end L. When I press play, it will display 7. Press any key to continue. This press any key to continue is because of our system pause. Alright, so 7 is what is stored inside num. Well, if I place num equals 9 here, while still having num equals 7, at this point when I run the program, it will output 9. The reason for this is, at this point here, num holds the number 7. At this point, it's going from top down, at this point it holds the number 9. After it holds the number 9 is when I am trying to output what is inside num. So at this point, it was 9. If I move this piece of code up, now I'm doing the cout before I assigned 9 to num. Now it outputs 7. Right? So the cool thing about programming is that everything goes straight through your program from top to bottom. And because it does that, you can reuse variables. In this case, num is being reused. First it's 7, then it's 9. Later it could be as many different numbers as you would want. But the current use for num right now, when I cout the num, was simply to display what was in its content at that time. I could copy paste here. Now I'm outputting num twice. The first num is 7. Whoops. And the second num was 9. So these are integers. I can do math with integers as well, such as 9 plus 2. So the first time I output num, it's 7. But when I do math like this, let's find out what it does with num. It outputs 11. 9 plus 2 is 11, so that's correct. It can even do mathematics by using other variables, such as int num2 equals 12. In this case, unlike this one, I initialized what num2 is going to store. Num2 is going to have a 12 to begin with, while num at this point has nothing. How do we know it has nothing? Let's display the first one. Notice there is no window. At the bottom, it says there is an error. Uninitialized local variable num was being used. So I'm trying to use num when it has nothing in it. So if I had said, well, num equals 0, then I could run it and it's going to display our 0. So always initialize or make sure that you have content in it before you try to use the variable. So in this case, we used num to display, but we had already placed a 7 in it. So it's no longer an uninitialized issue. Okay, there would be a problem if I said num2 equals num plus 12. So whatever's inside num plus 12, since once again num is uninitialized, I am going to go ahead and initialize it. Num equals, let's go with 0 again. Will it compile? Yes, it will allow you to compile, but notice that this 7 and this 11 are the values of num. I do not know what the contents of num2 is unless I display it. I'm going to go ahead and remove this portion down here, and I'm going to cout num2. Num2 equals 12. 0 plus 12. That's correct. Num2, if num starts off with 5, would be 17. So 5 plus 12 is 17. Let's see what this is. In this case, none of these variables are constant. They're all able to change. A constant is like this 12. When I say plus 12, it's always plus 12 as long as the program is running, unless I manually change it. This num variable right now equals 5. Later on, it might equal 12. It might equal something else. So because num is able to change, it is not constant. So num2, which is a changing variable, equals another num2 plus num. Let's evaluate this. Right now, num equals 5. And because I never say num equals anything else in this entire piece of code, num will be 5 throughout the entire code. Num2, though, is changing. Num2 equals num plus 12. So in this case, I'm going to write a little comment with 2 forward slashes. Num2 is 17 because 5 plus 12. Here, what I'm trying to say is num2 equals 17 plus 5, which means num2 equals, okay, so 17 plus 5, num2 equals 22. Let's find out. 22. Okay, so using variables to store and then using math with it should be no problem. That's what we are creating these variables for. In order for the computer to save values for a later time, those values are able to change throughout the program linearly from top to bottom. And at this point, when I cout, the answer to num2 was 22. Later on in my program, if I say another num2 equals something else, obviously num2 will no longer be 22 at that point. Alright, so integers are not the only things that you could create. You can also create a double. A double, I will call this one num3. A double holds all the same values as an integer. The only difference is that it also holds decimal points. So num equals 5. If I say num equals 5.5, will that be a problem? I'm going to comment out the double for now and see what my program says. It still equals 22, which 5.5 plus 12 should have been 17.5, And then here 17.5 plus 5.5 should have been 23. So what happened there? Since an integer cannot hold the decimal part, it is as if this decimal part does not exist. Completely ignores it. Even if it's a 5.999, it will ignore the 0.999 and it's simply a 5. It will not round up. So it removes the 0.5, it just kept the 5. Whereas if we have num3, now I'm going to uncomment this, num3 equals 5.5. I'm going to go ahead and after I output this value, I'm going to output num3. Okay, my previous program is still running. I'm going to stop. And I'm going to go ahead and compile again. 22 is the first one, which is correct. All of this value gave us num2 equals 22. Whereas num3, since I never changed it other than when I first created it, it still remains a 5.5. So a double could hold decimal. There are a few others that you could use, such as a float. A float holds all the same numbers as a double, except that the size of memory is smaller. We use a double only when we know we're going to hold a big number because, well, it has to keep track of the decimal point. So it has more information that it needs to save. Therefore, the size of memory is much larger than our integer or our float. We can hold as well a char, which stands for a character. The difference between the int, double, and float compared to a char is that the first three hold numbers, whereas a char will hold a character. So it probably would not be good to name it num5 because it's not holding a num. You can name it num5, sure, why not? But be aware that even though it's called num5, it does not hold a number. If I say num5 equals 3, let's see what happens if I try to cout num5. So right now we have our 22, we have our 5.5, and let's see what's inside num5. A weird figure. What if I decided to say num5 equals 67? It equals capital C? What's going on? Alright, so when I say a character, it's holding the ASCII value of a character. So the letter C is represented in the ASCII table. That's ASCII, which is probably in the back or in the front of your book. It holds 67 for C, which means probably 65 would be the A. We could try that out. 65 equals A. Okay, so if numbers represent characters, is there an easier way than to have to refer to the ASCII table each time? The answer is yes. If I place here in a single quote, I am telling the computer that this here is no longer representing the value based on a number, it's basing it on the actual character. So when I press play, it's going to output A. Okay, what if I try to output AC? It simply outputs C. Well, what happened to the A? Now remember, a character is a single character. It does not hold something we call a string, which a string is a set of characters. So it only holds 1, unfortunately. And this is getting very confusing calling it num5. I will call it a different name. Now you could choose any name that you would like. I will call this character, I guess. Which means if I'm going to see out, there is no num5 anymore. There's a character. Now notice as I was typing character, char started turning blue because char is a reserved word. You cannot name it something that is reserved. Let me go ahead and press play. There's our C again. It's the same thing, I just renamed it. And I will remove the A if I wanted the C. It'll be the same thing if you want symbols, such as the money symbol. So the money symbol is a character. All numbers are characters as well. So the number 8 is a character. You cannot add 8 plus 22 in this case because this 8 is a character, whereas this is an actual number that you can do math with. Later on you will learn how to do some math with them. And I still have this open. Okay, let's see what else. I did mention that a set of characters forms a string. So is there a data type such as string? String. Notice it did not turn blue. String. I would type it differently, but notice that it did not turn blue, but it did turn this different color. Let's see what happens when we compile. It fully compiled, so it did not give us any error. What's going on? A string holds a combination of characters. If a character is a single quote, then a string equals a double quote, such as the name Joe, or Joe 111. Okay, so since numbers are also characters, Joe 111 is fine. An address would be fine as well. But if I try to output the name, notice what will happen. There's an error. Go to the very first error. First ones are warnings, which are perfectly fine. Error. No operator found which takes a right-hand operand of type this or any acceptable conversion. Now this right here was done in line 20. If you do not have the numbers on the left side, it's fine. You could double click on this line here and it'll automatically take you to the line specified. Or you could simply, wherever you put your mouse on, it'll show you line 13 at the bottom. So this one here is line 20. Alright, so there's no way I can see out a string because the computer does not already come built with it. I have to include a library. When I include string, this string library tells the computer how I am to handle a string when I'm outputting it to the screen. Now the reason why is because this string is actually a whole bunch of characters. In reality it's an array of characters, which we're not covering yet, but it holds a lot of characters and it must know how to output them onto the screen. Now that we've told the computer how to do so, it will be able to output Joe 111. Okay, so the data types that we cover in this class right now is double, float, every now and then, character, string, and integer. Later on you will learn other data types such as if streams and other data types. probably 5 more, including if you create a class in 1337. Classes also form data types. So if there's nothing else here, that's it for this lesson. Thank you.